Welcome to this explainer. Today, we're going to be looking at the invisible engines that literally run our everyday lives. I'm talking about simple machines. We'll be exploring the foundational physics that let us actually manipulate the world around us, basically turning our human biological limits into absolute engineering triumphs.
So, our agenda for today covers three core concepts. First, we'll uncover the secret to work. Second, we'll look at the magic of advantage. And third, we'll dive right into the 6 simple machines. Let's get going.
All right, part 1, the secret to work.
So, what exactly is a simple machine anyway? Well, think about it. Without them, hoisting something like a massive, heavy stone column is, well, biologically impossible if you're just relying on human muscle alone, right? Simple machines step in as the great equalizer. They basically bridge the gap between our physical limitations and the rigid laws of physics. A simple machine makes your work easier through one of 3 absolutely brilliant trade-offs. You can increase the distance over which the force is applied, you can change the direction of that force, or you can multiply the speed or force directly. Now, you know, and I know, that you can't get something for nothing in physics, but you kind of can hack the system if you know how to make these smart little trades.
Moving right along to part 2, the magic of advantage.
You see, mechanical advantage is basically the ultimate multiplier. It's really just the ratio of your output force compared to your input force. So to put that into perspective, an advantage of 2 means the machine is effectively doubling your output effort. It literally proves that working smarter mathematically outweighs working harder. It's just so cool.
Okay, let's jump into part 3, the 6 simple machines.
So here is our lineup, the 6 foundational machines: the lever, the pulley, the wheel and axle, the inclined plane, the wedge, and the screw. And you know, it is genuinely remarkable to sit back and realize that every single complex piece of technology out there, and I mean everything, from a tiny mechanical wristwatch all the way up to a massive space shuttle, is essentially just a highly complex configuration of these 6 basic elements. Mind-blowing, right? First up, we've got the lever. It is simply a rigid bar resting on a pivot. So instead of trying to deadlift some massive heavy load and throwing out your back, you just apply a downward force on the opposite end. This allows the pivot point, which we call the fulcrum, to bear the absolute brunt of the work for you.
The real secret trick to the lever actually lies in the ratio of distances. Remember that mechanical advantage we just talked about? Here, it's calculated by dividing your input effort by the output load. Basically, the longer the distance from where you're pushing down to that fulcrum, the easier it's going to be to lift the load on the other side. It is a pure, perfect trade of distance for force.
Next up is the pulley. This one utilizes a wheel with a grooved edge specifically meant for a rope. And here's where it gets awesome. By looping ropes through multiple pulleys, you drastically multiply your lifting power, all while completely changing the direction of your force. You just pull down and boom, that heavy steel beam goes straight up.
Now moving on to the inclined plane, which is beautifully, almost ridiculously simple. It's just a flat surface raised at an angle. The big insight here is, again, that pure trade-off of distance for effort. Sure, pushing a heavy cart up this plane requires taking a much longer walk, but it takes significantly less immediate force than if you tried to just pick it straight up vertically.
Okay, this next one is super interesting. The wheel and axle is effectively just a continuous lever. It's a mechanism that unwinds from a larger wheel onto a smaller cylindrical drum that's joined directly right to it. So, turning the large wheel naturally turns the smaller axle with multiplied force. It's a principle that governs everything from heavy train carriages all the way down to the simple doorknobs right there in your house.
Then we have the wedge, which I like to call the great separator. Structurally speaking, it's really just 2 inclined planes placed back to back to form a triangle. When you drive a wedge downward, it actually transforms that vertical energy into a sideways splitting force. This applies to so many things, whether it's an axe splitting a log of wood, a knife cutting your dinner, or honestly, even your own front teeth.
Finally, we arrive at the screw. Now, while it obviously looks entirely different from a ramp, a screw is actually just an inclined plane that's cleverly wrapped around a central cylinder. By turning it, you translate rotational force into an absolutely immense downward clamping force. It is just such an elegant piece of physics, and it quite literally holds our modern world together.
As we wrap up this explainer, I really want to leave you with a bit of a challenge. You now understand the core mechanics of all physical work. So take a second right now and just look around your room. Which of these 6 simple machines can you spot hiding in plain sight? But more importantly, I want you to consider this. Even the most cutting-edge robotics and wildly advanced aerospace technologies we have today, they're still completely reliant on these exact same 6 ancient principles. So it kind of makes you wonder, have we truly ever invented anything new, or have we just found vastly more complex ways to spin the exact same 6 wheels?